this evening I'm going to show you how to do the gears on this dryer gear. The first thing to do is you draw your basic plate, which is the 5 7/8, right? Whoa, that didn't come out good. Let's try that one more time. The 5 7/8 diameter exterior piece, that's what this is. And on that piece we're going to create a new sketch. So this guy, right here. So I drew that already. We're going to create a new sketch on that face. So I'm going to go normal to pick that face. Now, the thing to remember when you're looking at these gears, you know that they're 5 degrees apart. Now, instead of thinking about making the gear, what you're really making is the cutout, because that's how gears are made. They're nubbed out. If we look online and look at how is a gear made, you're going to find out, as you look at this imagery, a lot about gears is so they don't interfere with each other. See that there's a lot of, you see how you see these rays going out, different diameters. And yes, the gears actually kind of like have an elbow to them. They have a curved interior wall if I ever zoomed in on them. We're not going to go that deep into the gear design for this class because this class is not about gear design. But there is actually a lot of math involved if I'm going to do a real gear. For our purposes, we want to make sure that at least they have a V kind of shape to them, all right? Just for the sake of this conversation, because this class is not about gear design. That's a whole different, as you could tell, there's a lot of science and math behind gear design. That's not this class's job. This class's job is strictly Solidworks. So I'm going to show you at least how to facsimile a gear. What you see in the other image, the one that we have, these gears don't even look like any of the gears that we see there either. They look pretty squared off, to be honest, right? So whoever did this drawing also did that. So I don't know what function this is playing, but there are different types of gears. So I'm not sure what they're building here, but they look pretty straight side, straight wall. Nothing like what I would do if I was going to go into real gear design. See how all of them have a curved side wall? I don't see that at all in the gear that I'm looking at. To make this, though, I'm thinking of making the cutout, which is this element where the hole is. I'm looking to make this piece, these cutouts here. I'm not looking to make this piece, meaning this piece here. This piece is going to be the product of me cutting the holes out. That's the way to think of what we're doing. So to do that, we have to look at what information we have available to our gears. So when we look over here, we've got what information? We have the angle between gears. We have the interior diameter of the gears. So if I pick here, I'm going to draw a circle. My interior diameter of 5.46, so it might be 625 or something like that. If I had to look at, what does it say on the decimal chart? Anyone have an answer? Because I know you got the chart right next to you.
0.460935.
Ooh, say that one more time. 5.4 what?
4609375.
609375. And that's to what decimal? What?
That's a 59128.
Wow. Okay, maybe. We'll see. There isn't a 4625 in there?
Now there's, after that it's 46875.
Okay, good job. All right, good. All right, then that's probably what it really is. Cool. So when we zoom in, we know that we've got a 5 degree mark. We're going to use the center line for this work. Anyone want to guess why I'm using center lines? What do we know about center lines? Do they fight me when I want to make anything? No, they're construction lines. Inside SolidWorks, a center line is a construction line. That's what they use. Inside Inventor, another product some of you might encounter, they have center lines and construction lines. They're two different types of lines, but they behave the same way. center lines there really are intended for center lines. Here, they use them as like synonyms. A center line is a construction line. They don't care. So I'm going to drop in a couple of center lines. I cannot draw on this screen here. I'm only allowed to draw here because that's what I have access to. So what I'm actually attempting to draw, and I know this is going to be drawn very badly, mind you, but I'm trying to do like a little blow up. Your goal is to make this cutout. See that? That's curved, by the way. Bad drawing of a curve, but it's curved. Let me try that one more time. If I draw this way and this way, see how it's a little V-shaped? That's supposed to be a curve at the bottom. That curve at the bottom is this dimension. The curve at the top, this curve at the top, I know I'm exaggerating the curve, is this dimension. So your goal is to make this shape. That will be your cutout. To make that, you first have to define your centers. And your centers is the 5 degrees, which is from this distance to this distance. This is your 5 degrees. Appreciate I'm using a mouse to do this. So I'm not drawing this beautifully at all. Got it? So everything you're trying to build is inside of a 5-degree window. So when I come in here and I go from here to here, I type in 5. Bad move. The reason I say that was a bad move is because it went right over my other center line. You want to be very careful about that. So I'm going to scooch that over a little bit. There we go. Now I'm going to change this to, instead of 10 degrees, 5 degrees is what you're after. So everything I want to build is inside this 5-degree space. So what I'm zooming in on is this shape. So there's the 5 degrees, and I want to build this shape. To build that shape, I need a center, this guy. So I need a center line. Let me change colors. I'll use lime. I need to build a center line through here. So that's what angle, guys? 2.5. You got it. 2.5. So that's 2.5 degrees. So there's my center reference. And now I have a reference here that I need to account for. Let's put little X's there. Here, here, and here. I exaggerated these angles. They could actually be going to the center, okay? However way they connect, which means I need how many more lines? 2 more. I need a line from the center of this, from its center, this center, somewhere here, halfway to be precise, not somewhere. And I need another one somewhere over here. Not somewhere, at the halfway mark. So from here to here, this is halfway to what was 2, so 2.5, not 8.5, 2.5 divided by 2. And from here to here, ditto. 2.5 divided by 2. All right? I did it as a division so you could see it done. Just remember that. I always am showing you different commands or reminding you. I can do what? I don't have to remember the number. I can just type in the math. Remember that, please. So now you have here and here. You have 2 positions to work with. Because these look so horribly straight, you probably can get away with this shape. I personally don't like it. But you probably can because they give you no information about the tooth gear, do they? They give you any information. It's straight as can be. They look really, really straight. But they must have a small taper to them. They have to because it's a gear. You can't have straight gears. They'll bind instantly. So they got to have a little bit of a flare. The little flare that you're looking at is the tiniest of angles, literally 1.25 degrees. So you can draw right over this shape and just close this. And this little shape right here could be, hold on, there we go. Could be the object you're looking for. If we trim off, let's see, what have we got? We got to trim, come on you. It wants to trim the whole thing. Oh, that's because I don't have it. Trim the closest. There we go. So we trim off that end. Now, do we have a curvature at the top? No. Well, how do we fix that? There's two ways to do it. One, I could draw a circle. What's the other way? Convert entities. I use convert entities. Remember, Maria, you asked that question?
Yeah.
Why do I use convert entities all the time? And my answer to you is I'm lazy. I do it because I don't have to draw. The beauty of doing this is it's 100% connected to that shape. If I ever change that exterior diameter, guess what my circle's going to do? It's lockstep with whatever I do. That's the real reason, and that's where the real lazy comes in, because I'm looking for a high degree of efficiency. I want this dimension to control this bottom shape, and at the same time, watch this. Let's say I want to change this diameter right here. I make a decision later on, not me, it's usually the customer, and the customer says, I want that to be 7, 8 inches, I don't care. I want my gear to update. See that? See how it updated? That line just stayed with it. If I drew it as a separate circle and dimensioned it, then I'd have a separate item I'd have to deal with later. The goal is to not do that. The power of this product is in this. When I make objects tied to each other. When I do convert entities, that's what I'm doing. This, when I edit this sketch, using convert entities keeps that sketch that now is pulled from the other object, keeps it tied to the original parent object. So if I ever change the parent object dimensions, my sketch and this sketch and this feature changes with it. And I want that kind of control. I want things to work together in the design process. I don't want, oh, I changed this, now I got to change this. You want to avoid, as I like to say, the ketchup and mustard. Because that's when that happens. When things are not tied together, and then all of a sudden your entire drawing blows up because you changed one dimension. And you're like, whoa, I got to fix this. Oh my God, what happened? That will happen to you, by the way. By the way, it will happen to you. Oh, and by the way, it'll happen to you. Because you can't control what another person does. Like if you're working with somebody else's drawing, you're stuck with however way they chose to build it. So you might have a predecessor who's working on who had worked on that drawing, God knows when, 10 years ago, who knows, right? My drawings are still being used in the field. And mine are like, at this point, imagine, I've been teaching here full time this long, so imagine how long ago those drawings are. So I've been here quite a while. So when you think about that. So I got drawings out there that are still being used. So that they don't go away. So I'm going to trim this off. There you go. See, that's our shape. This shape is the fraction of the fraction of the fraction. The outcome, now, if I go ahead and extrude cut, did I do the right one? What do we remember about Solidworks? We have extrude as a unique and discrete command separate of extrude cut. Please remember that. Extruded cut is a separate command. So if I do not like that box. Go to isometric, there I see it. I'm going to go, not blind, I say through all. And I hit OK. There's my singular cut in this piece. Okay? It's got a very slight taper, barely a degree. This is what you then turn around in circular pattern, not linear, but circular pattern. Now, what do we remember when we had this conversation last class? We discussed how many teeth this thing has. 72 teeth. So, what angle? Equally spaced, 360. So, if we say it's 72 teeth, right? Around this perimeter. And the item that we're going to be using is this guy. If I hit OK, that's what I get. And that looks very close to what they actually made. So that's probably how they made it. When I look at this and I compare it to this, that's what they did. They didn't make it like a real gear, the way we would make it with all the work involved. They just made a facsimile. So that's what you would do. When you look at it head on, has the slightest, it's so hard to see. One of them looks off. Hold on a second. Which way are they tapering, guys? Do you see what I see? If I put a ruler to this, which way do you think it's tapering? Yeah, it's tapering inward. It's tapering inward. And we want it to flare the other way. You see which way the angle is going? So we actually want it, and I can't draw this, we actually want it to go this way. So we're going to take, they probably built it this way, to be honest, based on the look. Because if I look at the isometric of this thing, it sure does look like that. I hate to say that, but you know what? I can't, in all good consciousness, I can't go with this gear. I can't, because I'm going to have a rash. I'm going to have a rash if I go with this gear. I can't. All right, so we're going to fix this, because that looks like that, but no way. I can't work with this gear. So we're going to fix it, because we really want that taper. So in order to make a real taper, what are we going to have to do? We're going to have to break this one more time, so that we can get an angular position down here to up here. We need a taper inward going outside of the object, not inward going inside of the object the way we see it now. So we're going to edit our one sketch, because it's actually going inward. And that's going to give me a rash right now if I leave it this way. Even if we did the following, see this? I know this is the cheesy approach, but how much information has this client given us? Zippity-doo-dah. Okay? So I am taking a very liberal approach on this. I'm going to take the halfway mark on this, and I'm going to tell the customer, right? What are we going to do? We're going to inform the customer. We're going to do a blow up of this little section and explain to them what gear design we chose to use, right? Because that's the correct way to communicate, yes? Because anytime we make a change, now in this case, we're not making the change from customer specification because the customer hasn't specified anything. We're going to tell the customer, we're alerting them, hey, so what do you think this angle should be, guys? Any guess? The halfway point. 1.25 divided by 2. Fraction of a fraction of a fraction. You think this is a good enough fix? Sochi?
I made an art, but yes.
The arc is there. The arc is actually there. It's a very small arc, but the arc is physically there.
Yes.
Did we do it this way?
Yeah.
Off the center? All right, let's try this and let's see if it looks correct. Let's see if it's a reasonable solution. Ah, is this a reasonable solution? Now remember how gears are supposed to fit. We've seen them enough in different projects.
I've never seen one. Oh, wait.
Our gear inspector in the room was probably having... is there something wrong with our gears? Do you see anything wrong with our gears?
Everything.
Everything. Oh, yeah. On a huge scale. Yes, but... Say again?
I think it was the top.
Yes, you are absolutely correct. This is not going to work because you'll notice that the tooth is bigger than the opening, which means it cannot work with another gear of the same configuration. This can't work with any. It has to have literally a custom partner to it. So this is a no-go, a major no-go. It would have to have a gear that has teeth that are narrow with a large gap in order to literally work. But that's not how gears are made. Gears are all equal. They're equal. So in order to fix this, we actually have to take this one more step further. Instead of just hacking at it a little bit and cutting this down, we also have to equally do it here at the top, meaning that we need to have in this spot the same equal spacing. So you can imagine, look how split this thing is. It just gets split, slice to slice to slice. This has to be equally sliced. The product is getting in the way of itself. Hold on. Try this a little lower. There we go. All right. So 1.25 divided by 2, right? See that position? And we have to split it again on this side. Come on. There we go. So in here we need 1.25 divided by 2. So we can properly slice this thing. So now I have literally, I got to take these two out because they're actually going to fight this entire process. All right. So what do I have? I've got an inner arc and I have an outer arc. This is not extended enough so that you could see the full magnitude of the separation. These guys have, I'm going to extend these back out. I'm going to erase those two. These two dots are actually going to fight everything. So let me get rid of that one. Yes, I need to get rid of you. I might not be able to. Yeah, unless the end point is a split point of a curve. Got it. All right, so here we have a... See if I can delete that. I'm going to delete that. All right, which means I'm deleting. There's a little line there I'm deleting, and I'm going to delete this little line. Okay, so here we have our extended entities. And we've split this up pretty much as tightly as we can to find the right marriage from here. If we look at how this is going to work out to here. Because what are we looking for? We're looking at for an even count. To here, see? We have 2 here, 2 here, and we have 2 in between. And we have 2 here. And we're going to try that. That is how you end up getting an even tooth count, because you need literally an even count of teeth, or lack thereof. There you go. See this guy? If I mirrored it, it'll end up here. So you'll have 2 and 2. So it's 1, 2, 3, 4, 5, 6, 7, 8. You have to split it in 8s. If I hit OK, exit out. Ooh. Huh? What did I forget? If it's 72 teeth, how many cuts? Am I missing something? Is it supposed to be 73? You see how it moves just a hair? Is it 72? It's 72 teeth? Is the dimension correct? Say again? Well, that's 72 is what we're saying as far as the number of teeth. That's the number we talked about. But if I overlay this, now you'll see where the issues lie. Where's the issue? Do you guys see the overlay? Hold on. There we go. That might be clearer. Is that a little clearer? Okay, let me try to make it more. How's that? It's tough to see on the screen. I'm sorry. What do you notice? Correct. What do you? But what? Wherein lies the 5 degrees between teeth is correct. Did I pick the wrong spot? I'm supposed to pick this spot, right? Now watch. Let's edit that one more time. If I delete this line and delete this line, and instead I go from here to here. Because what does this represent? The center line. Now if I go that far out, let's find out. I know. I'm making us work at this hour. Say okay out of this. What now do we have a concern with? Wait, do we? Wait a minute. Let me do the overlay. So let's look. We've got from here to here, the bottom of the tooth, and we've got two angle, 2.5 degrees, yes? Or 1.25, sorry. 1.25 degrees. Do we have 1.25 degrees here? What is this distance? Let's check. If we make the measurement, how can I check? What are different ways for me to check? What can I do? I can do what? Create a new sketch. And then what can I do? I can convert entities, right? I can convert this entity and this entity, right? I can check the measurement. Now, what is it doing when I turn like this? Why is it doing that? Anyone want to guess why it's wiggling? Because it's at a slight angle. So it's asking if it's going to be aligned or not. From here to here, what's that dimension? It's saying it's reference geometry. That's all that error that you're seeing, it's saying it's a driven dimension. It's reference geometry. The only thing I want is to go to the umpteenth decimal place. If I get the same number in the umpteenth decimal place, what does that mean? Oof. 0.05, 0.06. Gosh, they're off by a fraction. I wonder if it's because of how I dropped the dimension. They're literally off by a fraction. So So it could be the way the dimension dropped. Let's check. Let me check the dimension from here. Can I do that? Won't let me. So what do I do? Convert entities. Let me convert that one. Dimension from here to here. That'll tell me if at least, because that's like a horizontal position. Also, so there we go. 0.06408,504 is what we're after. Do I have a vertical position of a gap? No. Do I have a horizontal position for a gap? No. But I have perfect alignment. Do you notice that? See how they're perfect? This physically looks like a gear should look, but without the obvious, we have the obvious issues with it.
Yeah. There's nothing.
But when I try to dimension this, that'll be the tough one to dimension because it's not horizontally situated. So this dimension is a tough one to actually dimension. So if I go endpoint to endpoint, see how it wiggles? It's like several different spots. That's closer, but it's still, I don't trust my position. That I got a different number now than I had before. 0.0595, 0.064. So it's a fraction off, but I'm not sure why. Because all of these are equally spaced. So it shouldn't be. What could make it off a little bit, guys? What's the angle? Let's see if I could project, convert one more entity. I'm going to convert this line. If I dimension from here to here, that's 17.88. From here to here, should be the same. Okay. Now if I take this dimension and check, this dimension and check, it's, yep, they're both the same. That angle measurement is the same. Here to here. Come on, you. Let's try this one. Ooh, it will not. Have to convert that one. Let's see if this one's any different. We could check arc length. Let's see if we could check its properties. Let's see what the properties are. That's the degree.
I think that they have not to be the same.
You don't think they're going to be the same, do you?
Because the radius, the other...
The two radiuses are different.
Yes, the radius is different.
So they're going to be slightly different because one is an interior dimension, one's an exterior dimension. But these two match. 5956, 5951. Again, I think it's where I'm positioning it. You see how it's off a little bit? This is not aligned with its... The way that I'm dimensioning this isn't perfect. I can't get a perfect position. And by the way, from our gear inspector in the house, can you get a perfect dimension in there?
Wait, what? I'm sorry.
The bottom part of the tooth, is it a floating dimension sometimes?
Yeah. I mean, it varies.
It does vary. In the real world. And that's coming from someone who inspects gears all day. It does vary. Slightly.
Yeah, we're doing some right now that are obtained. It's actually like a donation or whatever. And they're going to go into some things for like, I forgot what it is. But
That's
it's
okay.
medical stuff. And
Medi-
they're so tiny and they're so annoying. They're gonna work
That's okay. That's okay.
They're so tiny.
The point is, you're going to get a slightly different dimension on the root versus the crest. You're going to. Okay? Don't be frustrated over it. I'm just letting you know. But the angles are good. And if I look at the gap on the outer gap, if I go point to point on this outer gap, okay. First says even if we'll argue point to point down here, if I can get it to align, which is the tough part. See, I can't get it to align perfectly because it's on a radius. That is my biggest problem. So at the bottom I get a 0.8, and at the top I get a 0.19. Not 8, I meant to say 1/8. And at the top I get a 0.19. So there's a slight variance at the top and the bottom. But this is as good as it's going to get. But notice what it took to get it. You actually split this, here's the middle, and you're splitting this up into sections. So that way you can get that line. And your goal is that line, that angled line, in as common a position as you can get, understanding that it's going at an angle. Just keep in mind the points you're working with are at an angle, so they will be slightly off because they're going on an angle to a radius. All right, guys? But that's how you build it. So that's literally what it looks like. So within a, what angle again? Within a what? What angle? Within what angle, guys? I forgot again. What's the angle that we're working with? Yes, within a 5-degree. I know. Stop giving me the message. All right, go away. All right, there we go. I'm trying to clean this up a little bit so I could show you the dimensions again. Yes, I know they're all reference dimensions. One thing I find annoying about Solidworks, I can't just pick the edge of a dimension. And it keeps insisting. There you go. That's what you need. You need to be able to break up the image. Let me zoom in a little closer. Try to. All right, I'm going to go and edit the sketch so I can show you. We're going to bring everything in a little closer so you have a nice close-up. Okay? You need to literally break this thing up down to segments of 8. See that? See that? That's what you're doing. Let me zoom back in. There it is. 5 degrees. The 2.5 degree mark, you split the 2.5 in half, so you get 1.25, and you split the 1.25 again, so you get 0.625, and then tip to tip, right there. This inner radius is what radius, guys? It's this radius. I'm not making that one up. That's what the customer gave us. They said that the root radius, is diameter 5.46. That's the root diameter, not radius, diameter. The exterior diameter is whatever the other diameter was. I accidentally, did I kill it? No, I did not kill it. It's just in the other drawing, the other sketch. I'll throw it in here so you have it. This one, I don't have an option. It wants to come out as a radius, so I'm not going to leave it in there. But that's what you have to do. You're building the cutout. You're not building the gear. You're building the cutout of what makes up what the outcome will be, that you'll see the gears themselves. All right, guys? And that concludes this little lecture on gears.